All right, we are officially recording. So, quick announcement that I just want to make. So I found out, you know how sometimes you have to be admitted to my room and some people can just get in? So I think what it is if you download Microsoft Teams and if you log in with your UVUID, then you can just join the room and I don't need to intervene. But if you use the web app as a guest, then I have to add you. So anyway, I just thought I would let you know. Some of you may not care, but I have to admit you. And anyway, so that's why. Another question or another thing that I just want to make a quick announcement. So the test is Thursday. I watched all the videos that I was supposed to watch, and I still have some questions about it. And they did say that the testing center would help me write the test, or not write it. I wrote the test, but they would help me put it on Canvas, which I still don't understand how to do. But the tentative plan is I'm going to give you an hour from, see, our class is noon to 1. And so what I would prefer to do is if you take it within the hours, well, so I'm going to actually, let me back up. I'm going to give you guys 75 minutes. The idea here is 60 minutes for the test and then an extra 15 minutes for any tech problems you may have. So basically what's going to happen, the way I understand what's going to happen, although I haven't seen it yet, so I don't know, is you're going to need a web camera and you'll hold up your ID to the phone and be like, this is my driver's license or my student ID, I'm who I say I am. And then you'll take the test and you'll have, ideally you'll have 60 minutes to take the test and then the last 15 minutes you can use for uploading it. Now, you'll basically want to take, maybe your phone, you will take a picture of each page of your test and then you will upload the pictures. Or if you want to scan it in and save it as a PDF, that will probably be easier for me to see. Some of you have scanners, some of you don't. If you don't have a scanner, your phone is fine. If you do have a scanner, it will probably be easier for me to see and grade. So I will just, so you'll basically be uploading those. So I'm going to give you an extra 15 minutes just in case there's any tech issues. So the tentative plan is we're going to cover 7.1 today, 7.2 tomorrow. I've already posted the review. I don't know if you've seen the review, but the review is already up. So I got that up early this week. So you should be able, after class today, you should be able to do everything except for the ellipses on the review. Thursday will be just a question and answer. I'm not going to prepare a lecture. You've already got the review, and then you can say, how do you solve this? And so I will, basically it's just a question and answer day. And so Thursday, here's the point that I want to make. What I would like to do is treat this as our regular class. And so since our class is from noon to 1 p.m., if you take the test from noon to 1 p.m. as our regular class is scheduled, I'm going to give you an extra 5% on the total test extra credit. I am going to make it, I think I'm going to open it from 9 a.m. to 9 p.m. So if you have a conflict or something, and you want to take it earlier that day or later that day, you can. But if you want to take it with your class, you get an extra 5% if you take it during the regularly scheduled class time. Does that make sense?
On Thursday?
On Thursday.
Okay.
So does anybody have any questions about the test?
For the extra 5%, does it have to be within 12 to 12:50? Is that what you mean? Or you just have to start it by 12?
Well, you only get an hour.
Yeah.
So yeah, 12 to 1. I'm going to let you go till 1. So if you started at 12 and you ended at 1, there is going to be a timer on Canvas, and it will cut you off. So yeah, if you turn in your test by 1 p.m., then you get the extra 5%.
Okay.
And yeah, so I'll just do it that way. So some of you will be done early. Some of you, I could give you 10 hours, and I think some of you would take 10 hours. But anyway, anyway, any other questions about the test?
Wait, so sorry, I know you already explained this, but so we take the test through Proctoria, but we take it on Canvas?
So the way, I'm not totally sure I can answer this question, but the way I understand it is I'm going to probably post, I think, a PDF online. I'm pretty sure that's what I'm going to do, although the testing center is going to verify that. Now, some of you have printers, some of you do not. If you have a printer, I'm okay with you printing it out. If you don't have a printer, just get some blank paper, and if you want to use graphing paper, that's fine. Hopefully that won't be hard for me to read, but and then you'll put number 1, you write the question down, and then write the solution. And then number 2, write the question down, write the solution. So
do you want us to do it?
So it'll be just like a regular test. You can, if you have a printer and you want to print it out, that's fine. Print it out, just write on what you've printed, and then take pictures of it or scan it in, and then turn it in as an attachment. Does that make sense?
Yeah. Would it be easier for you if we like had one paper with the question and answer and then another paper with our work, so it's clear to see what's work and what's our actual answer?
Whatever you think makes it super clear is fine with me.
Okay.
I mean, if I were taking the test, I would probably print it out, and then you could see the problem there, and then I would just write it. I mean, I would treat it just like the tests that the 3 tests we've already had. You just write on the paper right underneath the question where it is, and but just make it clear to me. Realize that if you're taking photographs, if it's really dark, that's going to be very hard for me to read. So, try to make it as easy on me to grade as possible, because it's not going to be fun sifting through. I mean, let's say it's 4 pages of photographs for every student. I think I've got 65 students, so it's not going to be fun. I'm not looking forward to grading this test. I'd much rather use pencil and paper, but it is what it is. So.
Okay.
Any other questions on the test? All right. So today, believe it or not, I'm excited to show you a little GIF file on parabolas. And so I've got this little thing here. Hopefully, why does it do this? Okay, so this is a little animation on how to create a parabola. So the points that we want to make here are we have a focus, the green dot there, and we have a directrix, which is the red line here. And so when you see this here, the distance between the focus and the directrix, the midpoint is the vertex of the parabola. And you can see here the red line and the blue line, those are exactly the same length. And that is how to create a parabola. And so in this, and I wish I could pause this. I can't pause it, but in this little animation, we're going to concentrate. I almost said focus. We're going to focus on the focus. We're going to have to figure out where is the location of a focus and where is the directrix. Now, in real life, when you're using these, you cannot watch TV without a satellite dish. Either the cable company or the, if it's ESPN and you're doing a live event, they send and receive those signals on a satellite dish. And so also, I think if you ever watch ESPN and you see those guys holding those giant bowls on the sideline, especially for a football game, and they're trying to get the crowd noise, the focus is where you would actually put the microphone. And so the nice thing about a parabola is when the sound wave comes in, it bounces off the side and goes straight to the focus. So no matter where the sound comes, it's going to bounce off the side of the parabola and it's going to go to the focus. And so the focus is very important because you want to know where to put your receiver if it's a satellite dish, or where to put your microphone at the focus. Okay, so so this is kind of a little cool animation. All right, so let's open up. Oh, I don't have it open yet. Let me open up Paintbrush here. And we're going to talk about how to find the focus and the directrix for a parabola. And that's going to be the main thing. And of course, we're going to still draw our parabolas as well. So the first example is I would like to talk about is, okay, so we're going to have, you guys are probably familiar in the past where we had y equals x squared. So we're going to change our equation slightly, and we're going to say that 4py equals x raised to the second power. Okay, so this is going to be kind of the, you could think of this as kind of the general form or something like that of a parabola. This is a parabola with vertex at the origin. Okay, so when we have it in this form, your vertex is going to be at 0, 0. Your focus is going to be at 0 and P. Oh, and I forgot to mention, let me go back to this little animation here. The distance between the green dot and the vertex is a distance of P. And also the distance between the vertex and the directrix is also a distance of P. Now, maybe instead of doing that, I'll just draw a parabola because I need it to be still and it won't be still. So if I take here, so I've got my axis here, okay, so this is my y-axis and my x-axis. And if I draw my parabola here, something like this, oh, that's a terrible one, I need to make it more round. Boy, that's not very symmetric, is it? Hard to draw on these things. Okay, so once again, if we assume, let's say that this, oops, let's say that this is your focus, and then this, let me draw another line here. This here equally distance, and so this distance between the focus and the vertex is a distance of P. The distance between the vertex and the directrix, this is what we're going to call the directrix, is going to be the same distance P. Now, this distance, maybe I'll pick a different color here, from your focus to here is a distance of 2p, and the same distance, even though it doesn't look the same because I didn't draw it very symmetrically, this distance here is also a distance of 2p. Okay, so this red line here has an interesting name that most students think is kind of funny, is the latus rectum. Okay, and so that distance is a distance of 4p. Okay, so I might ask you, what are the coordinates for the latus rectum? Now, the other thing that I just want to mention here really quickly as we go back to kind of our the things that you need to know for this section, the directrix. Okay, that is actually an equation. It's the equation of a line, and the equation in this case would be y equals minus p. Okay, so we're assuming that the vertex is on the origin, and so therefore your directrix is just as far away as your focus. Okay, So, and that's for, I guess the other thing is that I will just mention here, if P is greater than 0, then it opens up. And if P is less than 0, then it opens down. Okay? So kind of in a nutshell, the things that you're really going to want to remember for the test and for your homework, did not draw, oh, I did draw a box, is basically this box right here. Okay? So, and then that's for, maybe I don't need the whole thing here. That's for a parabola that looks basically like this. Oh, it didn't cut. Oops. And just pretend that my parabola is symmetric. Okay, because it's supposed to be symmetric. Okay. All right, so let's do our first example here. And let's say that I want you to find the equation for a parabola with a vertex at 0, 0, and a focus at 0, -2. Sketch the graph. Okay. So let's see, who do I want to pick on first? So Landon, I'm going to pick on you because theoretically it's not a quarter screen and you, plus I have used typing instead of handwriting. So theoretically you should be able to see this.
I see it nice and clear, sir.
Oh, I'm glad to hear that. Okay, so how would you start this problem?
So the vertex is going to be at 0, 0. So you can sketch that, right?
Yeah. Let me go ahead. I'm going to draw my. Oh, hopefully, I'm going to make that a little thicker though. Okay, so here's my axis over here. Okay. Close enough, straight enough. Okay.
And then the focus is going to be at 0, -2.
Okay.
So instead, I'm trying to figure out how to explain it in words. You're going to essentially have your focus instead of on the original one, it's where it's at 0, positive something, it's going to be lower than the origin, so it's going to be 0, -2.
Okay, so we're going to go down 2 units here. And this is my focus here. Okay. All right. So it's going to be a parabola facing downward. Just be glad I'm not making you guys do the test in paint. This would be terrible. Okay. All right. So then, okay. So you've sketched the graph. Okay. Now we need to find the equation of this graph.
And that's where I'm lost.
That's where you're lost. Okay. So the key thing here, and I'm going to put this in red, is this is going to be your key equation right there. So so do you know? So here I'm just going to rewrite the equation over here. So 4py equals x squared. Now, do we know what p equals?
-2.
Okay. Do you see that, Landon?
Yes.
Okay. All right. So that's the distance from the focus to the vertex. So p is -2. So now you just need to plug that into this equation, and you get
-8y is equal to
Negative 8y equals x squared. Perfect. Okay. And that's your answer right there. Bang. So that was easy. Oh, I thought I was drawing a circle. Let's try that again. Draw a circle. There we go. All right. Piece of cake.
Mm-hmm.
You gonna like this on the test?
Yep.
Okay. All right, let's do another one. I think I said Landon, but I meant Joey. Let's do the next one, because Joey's the one who had problems seeing last week, right? Can you see today, Joey? Let's go back to black. We'll go blue this time, just to be a little different. Joey, can you hear me? Joey, if you can hear us, we can't hear you. Are you on mute?
Can you hear me?
I can now.
Okay. I'll be honest, I've been doing work. Like my bosses have been talking to me for a minute, so I wasn't paying attention to anything.
But can you see better this time?
Yeah, I can see great now.
Oh, good. Okay, so at least we fixed that problem. Okay, so let's pick on somebody else here. How about Riley? It must be your turn. Let me go ahead. I'm going to draw my axis because we need to draw this. So do you know what to do here, Riley?
Just draw a downward facing parabola.
Okay, downward facing parabola. We'll have to draw our scale later. Okay. So downward facing parabola, center is at the vertex is at the origin. So do you know how to find the focus and the directrix?
No, I'm not really sure about that part.
Okay.
Wait, I have a
So-
question.
Go ahead.
Is it downward facing because it's negative x squared?
Yes.
Okay.
Okay. All right. So we've got the key equation here, 4py equals x squared. Okay. So I'm just going to write that again. 4py equals x squared. Now, we've got a positive x squared here in our general equation, but you've got a negative x squared. So so how would we move that negative over to the other side?
Multiplying by -1.
Okay, so we could rewrite this equation. Maybe I'll pick the color purple. We could rewrite our equation as negative y equals x squared, correct?
Yeah.
Okay. Now that I've gotten it written in here, then therefore your 4p has to equal -1. Does that make sense?
Yeah.
Okay. And so if 4p equals -1, what does p equal?
-4.
Nope.
Wait.
How do you get rid of the 4 over here?
Divide by 4.
We have to divide by 4. So we have to divide
Oh yeah. -1/4.
both sides. Okay, so therefore p equals -1/4.
Can you explain to me why 4p equals -1?
Well, we're trying to get it to look like this form here, right?
Right.
The general, remember up here, can you see my red circle?
Yeah.
Okay, so we're taking this equation here and we're trying to make it look like this equation up here. And so in order to do that, this one has a positive x squared. And so I'm going to get rid of the negative and I'm going to put negative y equals x squared.
Right. I get that part. I just am confused by the transition of going from negative y equals x squared to 4p equals negative 1.
Okay, so in this case, I've got a 4p here has to equal that negative right there. So 4p has to equal negative 1 because 4p is the coefficient of your y equation.
Okay.
And so if we say that 4p equals negative 1, then you can solve for p, and p equals negative 1/4.
Okay.
Does that make sense?
Yeah, kind of.
Kind of. Okay. So yeah, basically what we're saying, we're trying to make it look like here. And so I can erase all my circles, I guess. So 4p is the coefficient of your y variable. And since y has a coefficient of 1, therefore 4p equals negative 1.
Gotcha.
Okay. All right. So now we need to draw our scale in here. Oh, I should have asked this on the last question, but I'll ask it on this one. Okay. So if I make that 1, 1, 1, and 1, Riley, now that we know that p equals 1/4, I'll circle that here. If p equals negative 1/4, I should say. Therefore, where's your focus?
Just a little bit below the origin.
Okay, can you be more specific than just a little bit below?
1/4.
What are the coordinates?
0, -1/4.
0, -1/4. Okay. All right, and then, well done. What is the directrix?
Y equals 1/4.
1/4. Exactly right. And so if I were to draw the directrix on my graph, I'll try to use a straight line here. It's going to be that line there, and I'm going to make it a little thinner so it doesn't look like the axis. Okay. So well done. We found the focus and the directrix, and we've drawn it on our graph. Okay. Are you guys liking this section a little bit better?
Yeah.
Okay. Better than matrices?
Mm-hmm.
Okay. All right. So,
Your real professor, I kind of like matrices better.
say it again, Landon. You were really soft.
I'm gonna be real with you, professor. I kind of liked matrices better. Weirdly enough.
Oh, you like the matrices better? You know, it's kind of funny because some people hate matrices and some people love them. So yeah, it's just one of those weird things, but cool. All right, well, let's do another one here. I'm trying to decide if I have enough room here. Maybe we do. Let's do this one here. So let's say we'll go green this time. A parabola has the equation 6x equals, nope, 6x plus y squared equals 0. And the focus, directrix, and graph the equation. Okay. I think I'm going to put it over here. So, okay, so who can I pick on this time? Joey, are you still working? He didn't answer. Let's go with Hallie.
Okay.
Help me with this problem.
So we want it to look like 4py equals x squared, right?
Right, except for our x and our y are kind of flipped a little bit, but yes, you're correct.
So is it fine if we leave, it would be 4px equals y squared?
Yes.
Can you do that or no? Okay, you can.
Yeah.
Okay.
So of course that will change things a little bit, but yeah, essentially we're going to change this into 4px equals y. That's the form that we want to get it into. Okay.
Okay. Would you start by subtracting the y squared?
Okay. So we're going to get 6x equals negative y squared. Y squared. Okay. Well, I made it capital, but I didn't mean to. Okay. Or we could also swap the negatives, right?
Yeah.
So let's do that. So negative 6x equals y squared. Must have my caps lock on, that's why. Y squared. Okay. Oh, now I got a capital X. Whatever. Okay. All right. So now, therefore, what?
I actually don't know what we would do next because do you want that -6 to somehow turn into a 4?
A 4p.
A 4p.
Okay, so the -6 is going to equal the 4p, right?
Oh, I see. Okay.
Okay. And so therefore, p is going to equal
-3/2.
-3/2. Perfect. Okay. All right, so that's going to be very important. Now, the question is, let's go back to this step right here. Okay. If I have 6x equals -y, so you've got an x, think of it this way. I'm going to ignore the 6 for a minute. You've got an x equals a -y squared. So does this open up, down, left, or right?
It opens down.
It would open down if it was a y equals a negative x squared.
Oh, but since it's x equals y squared.
Yeah.
It opens left.
Does that make sense, Hallie?
Yeah.
Okay. So this one's going to open up left. Okay. So if I draw my thing here, hopefully, oh, that's a little bit. Let's try that again. Okay. All right. So it opens left. Now, oh, you know what I keep forgetting to ask you guys? We need to find, here, I'm going to add another thing here so I don't forget. I want to find, here, I'll put it here. Find the coordinates for the latus rectum. We should do that on the other ones too. We will if we have time. Okay, so, okay, but before we find the coordinates for the latus rectum, we need to find the focus, right?
Mm-hmm.
So where is the focus?
Zero, -3/2.
You said 0, -3/2, but remember, we're not oriented up and down.
Right.
So
Is it -3/2 0?
So -3/2, 0. Okay. So we flipped. So everything in here is basically flipped. Okay, so if we're going to draw our scale here as 1, 2, and therefore our focus is going to be right in between those, about right there. Okay. All right. So if our focus is there, where is our directrix?
Positive 3/2, 0.
I think Landon said something, but he was super quiet. And plus, I want Hallie to see if she can figure this out.
Oh, I'm still going.
Yeah.
Okay. Your directrix is going to be positive 3/2.
Okay, so positive 3/2 is only half correct. What did you forget?
Is it positive 3/2, 0?
No. So your directrix is actually a line, right? So
What
you
was
have to
that?
have either, your directrix is a line. So there's a line
Okay.
here. So it has to have a y equals or an x equals.
So it is going to be a y equals. X
Nope, it's
equals.
going to
Sorry,
be x
sorry.
equals. Yeah, because everything's flipped in this case. So once again, if I am drawing my scale on here, 1, 2, my directrix is going to be right in between those. I'll make that a little less thick. So it looks like that. Okay. All right. So now the bonus question is, and I'll throw this out for anybody, find the coordinates for the latus rectum. How would you find those coordinates?
The latus rectum is just 4p, so would you just multiply p by 4?
Well, the distance of the latus rectum is 4p, but in order to find the coordinates, it may be better to use 2p.
Okay.
Okay. So in this case, 2p would equal
-6/2, so -3.
Yeah, the same thing as -3. Okay. So 2p equals 3. So basically what we're going to do, I'm going to have to change my scale because I did a crappy job drawing this parabola. But I'm going to go 1, 2, oops, 2, and 3. Okay, so this coordinate here, if I use my circle, what is that coordinate there? And what is this coordinate here? I'll open it for anybody.
-3/2, -3, and then -3/2 and +3.
-3/2, -3. That's one coordinate, and the other one is -3/2, +3. Perfect. Okay. All right. Could we find those on these other ones too? I forgot to ask you to do that. Let's pick the purple one here. We found the focus was 1/4. I never drew the focus on there. Let's draw focus. Though the focus is right here. Except for I didn't want to draw a square. Oh, that's got a square focus. That's okay. Whatever. That's your focus. So what is, I'll use this here. So we need to figure out, now this might not be drawn to scale. You can't trust that that's -1 and +1. What are those coordinates on this one over here? How would you find that?
-1/2.
To find the coordinates, would you basically take P and then plus or minus 2P?
P plus or minus 2P, you'd take the focus plus or minus 2P. Is that what you meant?
Yeah, basically.
Yeah. That's a good way to say it. Okay, so the idea here is, so the 1/2 is actually going to be the y coordinate, not the x coordinate. So we need to figure out what the x coordinates are. Oh no, I said that wrong. You're right. Hallie's right. It's -1/2. No, it's not. What is it? Maybe it's easier to do it this way. 2p equals 1/2 equals -1/2. Everybody agree with that?
Yeah.
Okay, so what are these two coordinates then? So are we moving x 1/2 or 1/4?
1/4. Are the coordinates 1/4?
Okay, so this distance here, I'm going to pick another color. This distance, I'll pick a little bit of a square. The distance between the vertex and the focus is 1/4, right?
Yeah.
Okay, and then the distance between this lattice part of the latus rectum and the focus is 1/2. It's twice the distance. So if I'm going with the x, this is going to be 1/2, 1/2, -1/4. And then this is going to be -1/2, +1/4. Does that make sense?
Yeah.
Okay, so my scale is definitely wrong on there.
Wait, why would it be +1/4? Because aren't you still down a fourth?
Oh, you're right. It is -1/4. You're very good. Very good catch there. Negative. That should be a negative. Okay. I'm glad Lauren was paying attention. Okay. All right. Well, I think we're out of time. So, by the way, I guess I should mention one other quick thing. I just noticed this in the book. I called it the latus rectum. The distance, maybe I should put the distance of latus rectum is 4p. Don't know why that put on the next line. This is also known as the focal diameter. Okay. So focal diameter and latus rectum are basically the same thing. I just noticed that they call it the focal diameter in this book. The other books I've used call it the latus rectum. Okay.
Okay.
All right. Any last questions before I let you guys go? All righty then. Well, I will let you go. The quiz is already up for tomorrow, 7.1. So as a reminder, I can't remember if I said this at the beginning. So we'll cover 7.2 tomorrow. Wednesday, we will have a review, which will just be a question and answer session. I've already posted the review up there. And Thursday will be the test. 5 points extra credit if you take it during our regular class time. Otherwise, you can take it anytime you want between 9 a.m., but it's going to end at 9 p.m. So if you want the full 75 minutes, don't start it any later than 7:45. Okay?
Okay.
All righty. We'll see you all tomorrow. Have a good one.